I'm going to officially invite onto the stage our master of ceremony for this panel, our moderator. Look at him, look at him. So this is Andres Carvallo. Of those of you that have not met him, which I think is not the case, CEO of CMG, co-director of CEDAR at Texas State University. I would love for all of the panelists to please come on. Thank you.
Thank you, Claudia. Can somebody give a hand for Claudia, please? And Curtis needs a refreshment. Can we get water to Curtis, Rodgers? Curtis, they're getting water for you. Is he going to the restroom too? Or restrooms are back here. Let's bring some water to Curtis. Hurry, hurry. Double, 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 double. And do you guys need water? You wait. You guys will wait. And hey, you guys over there. Hey, come over here. I'm sorry. I'm kind of rude. I always like to take over everything. I'm going to take my mask off. I think we have an amazing panel here, and it's, you know, the transportation guys really took the mojo to the side for a moment there, but you know, they can't do anything without us. So there we go. They need to come back. So I'm going to go around. You already met Curtis Rodgers, who happens to be a Bobcat, and we're very proud of him. And he's also an advisor to CEDAR in the advisory board of CEDAR. And I'm going to start here on my left, your far right, with Pat Meagher. And you guys can introduce yourselves real quick and tell us why you're here and what's your love with smart buildings and infrastructure.
Thank you, Andres. Let's see, I'm here because I saw a sign outside that said there was a free lunch, and I just happened to pull into the parking lot and got some tortellini, so thank you. No, seriously, let's see, I'm a product development executive for a long time, former CTO of Flextronics, former VP of technology for Katera, and have moved, you know, from traditional products, you think computers, laptops, cell phones, things like that, into the building space, and am currently working on trying to reinvent or digitize the process by which you build buildings, focus mainly right now in single-family home, but lots of experience in multifamily as well. And was fortunate enough last year to talk on the same panel about some of the technology enablements that have been happening within the smart building, smart infrastructure space, and even maybe have some practical experience we could apply, you know, as part of this panel as we go. So thank you for the introduction and being here, and look forward to the discussions on the panel.
Thank you, Pat. John?
Hi, thanks, Andres. My name's John Dwyer. I am currently co-founder of a new startup called Tynt Technologies, which is a spin out of Stanford and University of Colorado for a new technology for dynamic switching. We're targeting residential windows. So pretty excited about that. Prior to that, I was worked with Pat at Katera. I was heading up advanced prop tech investments we were doing there. And I also have a long history before that outside of construction tech, just in product development. I was headed up wearable technologies and connected home products for Flextronics. I was with Flextronics for about 20 years.
Excellent. Thank you, John. And Eddie?
Eddie Demaj. I'm one of the co-founders of a company called Kode Labs, which is in the smart building space. We're a software company that essentially integrates all building systems, from core building systems to IoT, normalizes all that data, and then makes it possible to visualize, control, and analyze. And it's a completely vendor agnostic open platform that could tie to essentially any other system. As far as background goes, previous to Kode Labs, I was with a company called Rocket Fiber that I co-founded and exited last year, which was actually in the Google Fiber space, or in, you know, different cities, but similar model, except we touched, I think we touched a lot more than Google does. Google does primarily residential. We did managed services and commercial as well. So I'd love to have that conversation about the company that you know, you mentioned during your presentation, Curtis.
Sure. Excellent. Well, so you know, we had our prep call and we talked about certain things, and one of my things about if you go back, if you were here on Monday or earlier today, I truly believe that these three mega trends, digitalization, decentralization, and decarbonization, are really going to railroad everything that we're thinking and doing. And so you got to either, join the bandwagon and figure out how you fit into it, or you're going to be like destroyed and annihilated. So when you think about that, and then you think about the focus that we have on infrastructure at Texas State and the work we do at CMG, we truly believe that there is an amazing convergence of titanic proportion going on between buildings and homes, and then utilities, electric, water, and gas, and cities, right? So if you think about the building, a building like this one is a component of a city, a community, but it's also a service element into an infrastructure delivered by a gas, electric, or water utility. And so this building block, right, like Legos, today they're inanimate objects, they're highly analog, even though we do have electricity in here. And this is Pedernales Electric Co-op doing a good job. We haven't had an outage today. The flickering is minimal, but there is some flickering going on. And these buildings, in my opinion, need to not only become smart, but they need to really transform dramatically what they do. They should become a power plant. They should have a heliport on top for the VTOL thing landing. They need to be dynamic and move around. And just like you have plexi walls, all these things could be done differently in the way you do the lighting and the walls and the windows, and everything should be rethought and reinvented. Maybe it should be more like a circuit board printed on a cell phone. And so I wanted to talk about what is going on, how the transformation is happening. There are clearly building blocks, and automation has been going on buildings since that I can remember, with standards like X10 and so on, for about 40 years. So Pat, give us a sense for what has been going on in the last 5 to 6 years, and what's happening right now. There's a bunch of companies trying to build the next building technology of the future. What's happening?
Well, let's see. So there's quite a few things that are happening. Over the years, what I've seen and what I've been trying to promote is more the adoption of technology. Technology that many other industries are quite used to leveraging and using, but seem to escape the construction industry really almost at an amazing level. So I've been through a couple implementations of IoT systems and rollouts that were aimed at sort of productizing the buildings from the standpoint of maybe enhancing the safety and the health and the convenience for its occupants, and that can mean lots of things depending on the type of building, into some of the specific technologies like sensors and data collection and big data management, which I agree with something that was said earlier. It's that it creates a lot of noise and a lot of data that really doesn't create a whole lot of benefit, right? So we've now moved, in a lot of the work that I'm doing, we've moved towards sort of digitizing the process by which you construct and manage and implement buildings quite differently, much more akin to things like John and I have been doing. Every product in the world, if you think of a computer or a phone or an airplane or a bus or a car, they're parametrically 3D designed and digitized from day one as just a normal course of business. It's been going on for 20 years like this. And yet when you look at buildings, everything from single family home up to high-rise commercial, they're all still bespoke. They're all still one-off. Crew A does something different than Crew B that does something different than Crew C. Nothing is repeatable, nothing is scalable, nothing is cost-effective. And to me, it's just astonishing, right, that can actually exist in one of the biggest TAMs in the world. So what we're trying to do is actually bring technology and processes to make that faster, more efficient, more repeatable, and more scalable. And I think that we're starting to see a lot of benefit in that, that there's companies out there that are starting to adopt these methodologies and this type of thinking, and the idea that you can really create supply chains around this, and you can have them be extensible, and you can have them be competitive, You can have them add value in terms of dollars and time and things like that. So a lot of focus there, but I think there's still plenty of room for emerging technologies and even well understood technologies to be further integrated into buildings and into cities. Again, for the purpose not just to create technology experiments, but to really enhance the safety, the security, the convenience, and the comfort of occupants or human beings ourselves as we go and interact in the future with our homes and our offices and things like that.
So John, you may want to chime in here and give us a little more flavor into materials. I think everybody can set up a Wi-Fi and add a bunch of little gadgets and you call it a smart building. To me, that's not a smart building. There's a bunch of add-ons to a physical infrastructure that doesn't do anything. What's going on with these buildings really becoming intelligent and the advancements and all that?
Okay, sure. Yeah, I'm going to get on materials, but I want to compliment something Pat said first. I think that there's some analogies to what's happened in like the automotive and mobility industry that are going to really drive some innovation when it comes to like the building as a product. And it kind of gets into a lot of the automation that we think of in the traditional construction industry is about managing the building more efficiently, building the building more cost effectively, addressing shortage of construction labor. But I think what's really coming is this impact of user experience and becoming more ubiquitous of the people in the building and that's going to get into these active materials opposed to passive materials. But I think that really starts to, when you can look at products or components that are going into the structure that people start to interact with differently and start to expect different things out of it, it not only changes the experience, it drives new revenue models. And so I think my analogy back to automotive is it wasn't too many years ago when the automotive companies had, and you look at their infotainment systems, it was all proprietary. It was based on longer life cycles of the whole platform. And then when you started to see people really driving iOS and Android Auto, now it's not just a common integration. So I think there's a collaboration coming with technology that's going to be a shift from maybe, it brings in new technology companies we see from the traditional construction technology companies. And I think for us, when we look at like the windows that we're working on, for example, it's starting to drive materials where active electronics and sensors are embedded into the primary substrate. So glass is a great example, driving lower cost solutions to that. And we see once you start to have a roadmap where you can see the cost being, the cost effectiveness, it opens up the value proposition to be quite a bit different on something like a window relative to not only controlling energy and heat gain, but also integrating with the lighting and optimizing that in the building. And then it just kind of goes from there. There's other technologies that start to go on glass that get all the way to things like entertainment. So I think that I like to see the materials and the products there that we would call, say, components that go into a building that, the ones that can hit multiple advantages, like having, for sure, energy efficiencies, but then also create a wow factor for user experience and also align with architects to be able to do really cool, neat, innovative things that can really start to shift. I think those come together. And as those trends start to drive, it just helps for investment into driving some of these new technologies to a cost-effective standard. Absolutely.
Curtis, last 5 years, you've been doing this for a while now, but things seem to be accelerating. What is happening? Where are we heading? Are we heading into a next generation of intelligent buildings? What's going on?
Oh, there we go. So, the reason why we look at it as a spectrum, like the construction space, is because it's hard to make, a general statement because, data centers are very sophisticated buildings and are being built in new innovative ways faster and faster, and they're amazing. But single-family homes are pretty much the same, and there's people trying some wacky stuff, but the permit process really stifles all innovation in that market. So, I'd say it's market by market, and the composite bridges that are being built in Florida And you know, you have to understand the landscape. You got to find out, you know, you have to do like a survey and say, okay, we're looking at like bridge infrastructure, and then okay, where is that happening in an innovative way? Because that's more, you know, municipal or geographically, you know, there's little pockets of innovation for that. And then if you're looking for like single-family residential, there's some cool stuff going on. Typically on military bases where they don't have to really abide by any kind of permit process, and because you really can't mess with structural products in innovative ways in any kind of like, you know, quick timeline. So yeah, to answer that question, yeah, depends upon the geography and the segment. But yeah, let me think about where our building. So we have a portfolio company called Connect Homes, and they make modular single-family homes. And, you know, that is a extremely efficient way to build quality products. But there's still like this like change in consumers where they'd have to be buying a product and not building their dream house. And there's also the mentality of, you know, modular homes, and you know, there's a lot of barriers for financing and stuff like that. But that would be where like we're really pushing and trying to crack the nut on smart buildings, is making single-family homes more affordable, and you know, it's really infill development. So tear downs, that type of thing is what we're focused on.
So clearly, you know, real quick to set up this for Eddie, you know, when you talk about innovation, greenfield's easy. You build a brand new house, your new architecture, and you go to a new country, you build a brand new city if you can afford it from scratch. One of the challenges that we have in North America and in the United States, you know, being the global superpower we are for 240 years or so, is that, you know, it's really difficult to build new things here in most places because it's already built. And so take, for example, a company like AT&T. Anybody from AT&T in the house? So AT&T is a good old customer of CMG. And AT&T has 60,000 buildings in the United States. And they need to manage these things. And these things, you know, have lights and this and windows, and things break, and chillers and pumps. And so, Eddie, your company is in the whole managing these things, ones that have been built. Walk us through why should I call you? What is it that you make that is so unique, and where do I see this stuff running around?
Yeah, so there were some good conversations earlier, you know, in the different topics. And I think at the core of everything, at least our view at Kode Labs has been, having kind of been in this space, both on the infrastructure side and on the, you know, smart building side, is that, you know, at the core of it, if you can't figure out how to normalize the data on anything, that's transportation, that's building, that's anything, you're just not getting there. That's one. Two, my personal view is that you can't have, you know, there's a lot of talk about smart cities. You can't have smart cities with dumb buildings. It just doesn't work. And, you know, three, we spend, you know, a lot of our awake time in commercial buildings. Residential is, you know, family, sleep primarily, at least for me. And commercial spaces is where we spend most of our time, and at least as professionals. So from our perspective, and the reason we got into this space is that we felt that the big players in the space, from, you know, whether it's Siemens, Johnson, you go on and on and on, you know, have been building good hardware, but frankly, the incentive hasn't been there for them to tie with everybody else. And we thought we could build a software operating system that allows for integration and normalization of all this data into an ontology that allows for scalability and allows you to avoid things like what we talked about, like the noise that, you know, I think traditionally, I agree with you guys 100%, has been a big deal. You know, a building gets 75,000 alarms, and it's like, so what's happening, right? That's the space that we've stepped in and said, hey, look, if you use our operating system, we can help normalize this data and help you scale from core building systems to IoT to operational software, and really tie to the smart city, and kind of build, you know, help build the building blocks that allow you to again, a scale across, you know, a large portfolio. So anyway, so I guess at the core of everything for us, it's you can't do any of these things unless you have a way to normalize data. You can't normalize data unless you have an ontology that allows you to scale, which is why, I mean, even Google, we all use Google all the time. The reason Google is because they figured out this back-end ontology piece. Well, smart cities don't have an ontology that's, you know, anybody could tie to. Buildings do, thanks to Google and some of the other companies. We've added quite a bit to that. So that's our view. That's how we got into it.
Gotcha. So Curtis, is there any success stories or so, for example, what happened with Sidewalk Labs in Toronto? Why did that break out? I mean, It seems like it was going to be a phenomenal thing, and then the partners walked away.
Yep.
Was it the money? Was it the rules? Was it the code? I mean, I don't know what you can share, but
Yeah. So I think Sidewalk Labs would be happy to share lessons learned, and I think it'd be appropriate for me to tell some of the, you know, the not so flattering things, but, you know, it's all in the name of, you know, innovation and trying and failing.
Mm-hmm.
So I remember we got them to invest in the fund, and then they just put the team together in New York City and called us and said, oh crap, we just found out all of the land that Toronto gave us is contaminated. What do we do with contaminated soil? Ooh. And we said, oh, congratulations, you're behind schedule and over budget. You're just welcome to construction. And yeah, it was just one thing after another. They just did not know, they didn't have a very good plan. And because of one of their core values of sustainability, they didn't like our response of, you know, embank it somewhere else. That's what you do with contaminated soil. You either spend $40 a cubic yard cleaning it or putting it to waste, or you consume a tremendous amount of energy, you know, burning off all of the contaminants. And, you know, they just got totally distracted, you know, like trying to, you know, fix all the world's problems as they hit every single one. So they just had there was no one on that leadership team who ever built anything. They hired one developer who forced them to buy a plotter so they could actually print things out and talk about maps instead of like only working on screens. It's just, yeah. So they've now gotten out of that. They have no interest in building a city of the future anymore, and now they're going into infrastructure investing.
Yeah.
So that's the new focus is Sidewalk Labs infrastructure partners, something like that. So they're starting to learn and adapt. And yeah, construction is very difficult.
If I can add,
Yeah,
very
yeah.
familiar with Sidewalk Labs, know their founder, the whole nine yards.
Yeah.
Great people, horrible at building technology, absolutely horrible.
Bonkers.
And learn some, you know, beyond expensive lessons.
So in other words,
I think I'm glad they're investing in you guys and letting you like run with it.
easier said than done, as they say.
Yeah.
It's just not their forte. I think they're better at letting, you know, companies like you guys invest where you can go deeper and do that. Which
So
again, I'm glad
on the other
tweaked
side of that equation, what would be a great example of any of these new things happening? What would you point out?
Yeah. So there is, like, as far as like positive outcomes,
Yep.
you know, there's really not a whole lot. It's, you know, you have, like, I'll tell you one of the snafus we hit with Connect Homes. You know, we worked with Connect Homes for 3 years before we invested, and they really knew how to build a house as a product. And we were like, that's great. These are amazing architects, and they could really crack that nut. But they didn't know manufacturing, so they hired a VP of manufacturing. He turned their facility into a true manufacturing production line. Mm-hmm. That's when we said, okay, we're going to invest. Well, we were naive about how many other skills you need within the company to really serve the market. And the finance and like developer aspect and the mortgage loans, all that stuff, that's something that now we're kind of adding to the organization. So it's, you know, it's so challenging that the teams are improving over time, but it's more like these are rare birds. It's very exotic to get a innovative manufacturing person, construction person, architect, product designer, and now getting into finance and development, all that stuff. Like, no one has ever assembled all of these people in a company before. So I'm not surprised that there hasn't been much progress, because we're like, after each failure, all of those lessons learned are incorporated.
Right.
Or every time that we run into another issue, we're like, oh, damn, we need another vice president of something. Like,
Yep,
you know,
yep.
so it's slowly going, but we're making progress. But
Yeah.
there's honestly not a lot of like big successes. If you want to know what good looks like, you probably look at the Stanford campus. Their campus has been collecting facility data in a structured way for longer than anybody. And really that's where the facility teams for Google and Apple and Amazon and everybody
from.
studies Stanford campus. They're probably the best, and they're Stanford. They'll just say like, hey, we built it this way. And yeah, so that campus would probably be the most innovative, smart, facility, smart buildings that we've ever seen.
So guys, you have something to add?
Yeah, I have a
Thoughts on that. So, by the way, I would suggest that Katerra's investment and work and ultimate explosion makes Sidewalk Labs look like a wonderful success, right? but in the process of that, there was just tons of learning. This is an industry that is very challenging, right? And from my previous life, all the ideas about incorporating technology and productizing and stuff, the construction industry in general doesn't think that way. And I think you guys are right that it's a diverse team of people that can bring together, the traditional understanding and needs of buildings, and maybe even building, smart buildings, smart technology to build them, and digitization. But then also the combination of people that do have product mindsets that, know how to like design, know how to scale, know how to create supply chains, know how to do things like build factories that actually can output a product and do it more than once, and actually create economic benefit. So I think still, to me, this industry is at the very front end of all those things, and there's a long, long ways to go. But it's also a very rich and challenging environment that I'd find to be quite stimulating, right? It's far from cut and dried, right?
I'd want to simplify something from just a whole career of setting up factories all over the world, some of them very customized. And I think in the construction, and even maybe some of the most, people that look at like modular homes and think they're, it's really innovative. I would argue that, when I've gone through these factories and I see the factories, when you're really innovative, and I go into a factory and I've had to create the factory because it's the only way to manufacture what's been designed, you're starting to get into change. Most of what's happening now, the factories are just kind of shifting what could be done in the field. And I would argue with advancements in manufacturing technology, if you don't change designs more than what we're seeing now, you're better off moving the factory out to the field. Yeah. Because the spoke and hub, it has all kinds of logistics problems. So to me, that's kind of what I was taking back in, what I realized going into Katerra, that it just comes back to there isn't truly, what I don't see out there is a true, like let's say in modular homes, a true innovation from a pure product design, that it's been digitally put together and we're actually creating something that we can't make with the methods we have today. We have to create a process to be able to make this advancement. I just think that's a good trigger to look for. When you see something like that, whether it's a structural member or whether it's some finished component, and you're like, holy crap, now I have to figure out how to make that. That's.
You had to follow up?
Yeah, I just want to add on to what John was saying. So again, one of the great learnings is really around the logistics and supply chain. So just because you can break a building into pieces and into technologies and build it in a factory doesn't mean that you can deliver a faster, better, or cheaper product. We found out what's your factory strategy? Well, we have a strategy. We're going to build 5, massive million-square-foot factories in the U.S. and ship all of our parts to wherever the job sites are. And this just was a massive miscalculation of what it needs, because the cost and the time related to that outstrip any benefit of trying to productize to start with. So then, as John was saying, we evolved to the idea, well, wow, instead of 5 big factories, I probably need 100 small factories in every region, right? And so the whole strategy around how you deliver products and technologies into the smart building or smart living space is just completely different than what the traditionalists have thought and what's actually been going on for for the last couple of years. And I think you'll see these shifts underway today where you say, hey, if I'm going to build a bathroom or a kitchen or a wall or a roof or a panel for a building or something in a factory, it better be pretty damn close to the site where it's going to go. In fact, maybe the factory is a tent on the site with some of the equipment, so I can really efficiently do that and make use of all the digitization techniques that are required, again, to make it scalable and repeatable. So changing a lot.
So maybe the factories are Home Depot and Lowe's, and the do-it-yourself movement is here to stay.
Yeah, I mean, it's like, it has to be a product if it's going to be built in a factory, because, yeah, you don't want too much design freedom. Right. And so it's going to be, single-family home, something simplified, low-density multifamily, ADUs. We have a homeless shelter product, Connect Shelters. Right. It's kind of like a marriage between a building and an Airstream, and so it's very easy to service and move around, all that. Right. But when it comes to infrastructure, your columns and caps and bridge decks and stuff like that, that's a huge opportunity for the nation to standardize on, highway construction, and then you just make the standard, precast concrete, whatever, and that could be, it doesn't happen right now because Texas wants whatever the cool new design is in the concrete. Right. But that would be a big opportunity. But then you're dealing with the government process, so it's very difficult. So I agree on getting the factory out in the field, and then it's an information management problem.
Right. The other thing, just is maybe a little bit off of smart buildings, but I think this is one more comment that I found in, especially in buildings that are in residential and say mid-rise, multifamily, garden type style. There's not, that productization is, when you come from the product world, you're looking at this tolerance, stack up tolerance analysis from a design for assembly from the very beginning. And what a lot of the companies tend to do is they focus on the floor systems, the wall systems, and it's the foundation piece that when you see these assemblies going out, especially as you put a higher level of value in a factory, and when you have to go out and it doesn't fit right, because you haven't done that analysis and you got to rework it, that's a killer. And so I think we encountered that quite a bit. And I'd say, having ways to do the foundational pieces of these buildings that's very accurate. So when you deliver something from a factory, you know exactly it's going to fit together is a key to making the efficiency work.
Right. So if I told you guys that I truly believe, as I wrote in chapter 7 of my book, The Advanced Smart Grid that you can buy over there, that all these buildings are going to become power plants, right? And so all you need is to add some kind of local generation and local storage and a little retrofit in the building. I mean, is this possible? Is this attainable?
Yeah. So we're not investors, but we're good friends with a company called Viking Cold, and they've got a phase change insulation that you can store energy in. So PG&E can dump megawatts worth of power into these cold storage facilities, and that is really beneficial to the power grid, that kind of thing. And yeah, I mean, that's an example of a building that is a battery. Mm-hmm. And it's, you can use that insulation on your,
right.
cooled water and all that stuff. It's a cool technology. Yeah, but, there's just, it's not going to work in every instance. It's all, each application is unique, and you're going to need a different solution. Right. But yeah, we're definitely really excited about energy for buildings.
I mean, because the reason I asked for this is, if we're going to really save the planet for generating the next 400 gigatons, it's going to take us into the meltdown that Microsoft and others are predicting by 2030. It's 400 gigatons. We generate 40 gigatons a year on CO2, the planet. Yep. And we need to, if we add another 400 gigatons in the next 10 years, we're dead. According to a bunch of people, I don't know, but so can we do something about these damn buildings and turn them into part of the solution instead of sucking all this energy all the time?
So let me jump in and grab that one, and I appreciate that question. So again, not being from the construction industry, I'm absolutely flabbergasted by the carbon content that's created in construction. It's the biggest contributor to carbon on the planet. 38% of the total carbon deposits come from construction. The next biggest industry is automotive, which is only like 21%. It's just astonishing to me. So as part of what we've been doing, if I told myself if I'm going to be in this business, it's a moral imperative to start to change the outcome. And I think the fundamental change starts through materials, back to kind of what John is doing, looking for substitutes for, concrete and cement, which are, the most versatile, widely used, and horrendous product in the world. Things like drywall, things like we talked about earlier, like, rebar that's now becoming composite materials, windows that actually become energy harvesters and saving elements that can be, blacked out and conserve energy. These are all incredibly important technologies that we absolutely have to adopt and speed to be able to, stop us from killing the planet, for crying out loud. We may already be at the tipping point and not even know it. Yeah. So I think all those things you said, Andres, are important, and the fact that maybe buildings and homes become power generation and conservation, elements or nodes of the network versus consumers of that, it's imperative that we do that and we drive outcomes towards that end.
Yeah, I also think that we had to, our lead investor was Energy Impact Fund. So we had to show and demonstrate the original technology was developed under a DOE grant, but we had to show the ability to impact as like 1.5 to 1.8 gigaton through the potential implementation of dynamic windows just from, and when you did that and you looked at, you need to look at these puzzle pieces that are being impacted, because the primary part of that was impacting, solar heat gain and loads and things like that. But then there was secondary impacts like, well, if we have a product that goes completely opaque to clear, we don't need blinds and curtains, and there's a whole nother industry producing those products that we ended up having to factor in to kind of show that we thought there was more of an impact there than maybe what some of the original funds had thought. Mm-hmm. And I think that's a good, when you're looking at that impact, it's like how are you controlling the usage, and then the next thing is layering on. I think there's an opportunity for the technologies, like our technology blocks the light or lets it in, layered onto an optically clear solar panel that actually can collect and be able to generate power. So it's opening the door for these technologies to start to work together and kind of hit it from multiple angles.
Very interesting.
Yeah, we have a portfolio company that has an outstanding beneficial impact on the environment. It's the Cumulus Digital Systems. It was a spin out from Shell's research lab. And really it all started with Deepwater Horizon. And the Shell executive board said, whoa, if we don't get some help, that could be us. And so they approached MIT's Draper Labs. That's a big defense lab at MIT. And then as a kind of a spin out of a spin out became Cumulus Digital Systems. And it eliminates leaks on refineries. It eliminates leaks for any bolted assembly, and so it's being deployed at refineries around the world. And Shell wanted this to be out and didn't want this to be a proprietary technology. And so you've got these amazing former aerospace engineers and systems engineers from MIT now flying around the world and teaching all of these workers how to use the technology, and it's called fugitive emissions. So it eliminates fugitive emissions,
right.
And we're now getting investment for that company is tough because it's related to oil and gas, and that's kind of
taboo.
It's taboo,
Yeah.
But
that's a big deal. The savings are tremendous.
Yeah, I mean any refinery. 10 to 20% of the bolted connections there are leaking.
Yeah.
And to take that to zero is a big deal.
Oh yeah, billions of dollars.
Yep.
So Eddie, what do you think about all this? I mean, do you sense that your customers are happy with what you got and they're done, or they want to turn their buildings into a power plant and they're asking you how to do it?
So the power plant conversation we're not having just yet. I think we have in North America specifically, we still have 98+% of our commercial real estate, mixed use and so on still has a ways to go to just become get to a place where it just understands itself.
So it's efficiency right now.
100%. So the conversations we're having is, look, we're spending X amount of dollars per foot on energy. What can you do to help us lower that? And the tech that we've built, we're at that 15 to 25%, depending on where the existing building, like what type of, building and systems have been in there. Lauren, you're talking about, eliminating leaks in the space you're talking about. We're kind of in the space of eliminating leaks in like actual commercial buildings and making sure that things that shouldn't be on are not on, as an example. So that's the space we're in,
So clearly, power draw, climate management inside the building is key. Maybe presence and security. What about air quality? And is anybody asking you, I want to make sure that there is no COVID in the space. Do you have a COVID sensor?
we don't, but there's a lot of companies that are building all types of sensors. Our approach to the space has been that, there are companies that are buying, an occupancy sensor, an indoor air quality sensor, this, that, and the other. And it's, having to go to each one of these companies, platforms to view the data. Our approach is if you're buying this, that's great. But if you have our platform in, all of it can come into one platform. We're accounting for air outside. We have algorithms that we've built on the ML side that'll use what the, outside weather is supposed to be, 5-10 days out, to then make sure that we're optimizing the way that equipment runs inside. And then if your goal is to make sure that air quality is, at a certain level and you have these sensors, well, we're taking that data and then making sure that all of your building systems are pulling outside air, at the level that you need it to make sure that it's hitting the goals that you've set out as an owner, developer, manager.
So on all these sensors, I'm curious about one in particular. Does anybody care about CO2 levels inside the building?
Look, man, you run into all kinds of use cases.
If I'm in Mexico City or Beijing, I probably want to know, right?
Right, and it's just, I'll tell you, there are hundreds and hundreds of different use cases. You guys actually have a building here close to you guys called that'll go live at the end of this year, first quarter of next year. The latest called River South, which is right downtown Austin, and that'll be by far one of the smartest buildings in North America, if not the smartest. When you
let me guess, they're using your technology?
They are, but it's public. Absolutely, they are, because they've tried others and they failed. And this is, and you guys can reach out to them directly. But it's the interesting thing with that building.
So where is it again? What's it called? The building?
It's called River South. The building's called River South. It's right downtown Austin, and it's a partnership between the company that is ranked #1 for sustainability in North America, #2 globally, that is doing that, and they're the ones that have picked all the tech and kind of the way to bring it together. So it's a data-driven space that we live in, and it doesn't have to be a sales pitch. It's just things have to be quantified in 2021.
So I need you guys to react to several things that are really. Maybe you guys had a comment on anything?
Yeah, if I could just a comment, you touched on COVID, right? And technology with COVID and pandemics are also of interest to us. We developed an app that allows you to actually, from your phone, open and close doors to your commercial office space, so it controls access and egress, and it's run by cameras and sensors that detect, temperatures and things like that, so that you can maybe prevent people that have a high temperature from entering the building. So there's a lot of technologies that are emerging there that I think are very useful and helpful at this age of pandemics. And then also back to materials, there's a huge interest in a lot of the interior systems around antimicrobial surfaces and surfaces that are durable and easy to clean, which are again quite different than your traditional, melamines and wall boards and things like that are coming on to potentially, deal with the realities of COVID and pandemics both now and in the future. So that's a great area of technology and improvement and enhancement as well.
Yeah. So I want you to react to the following thing, and I asked this earlier too in my panel yesterday with the power guys. So does anybody here have a F-150? Does anybody drive a Ford F-150? Anybody? Okay. So you are familiar with the fact that Ford made an announcement. It's called the Ford Lightning. It's an F-150 that actually, if you get the upgraded model, you can run your house for 4 days out of the battery. So what would happen to our buildings, guys, if 100 of these trucks were in the building, and
in the parking lot?
And could I run the building with the trucks?
Well, let's see. I think those type of systems, even today, and and actually go back to the previous mobility panel, I think there's still a huge amount of challenge around power and power densities and the ability to sustain it. You can, in burst mode, for periods of hours, gang F-150s or batteries together and run your building. But it's really a sort of a specialized event. It's not something that you can smooth and sustain over long periods of time yet. I think we're bound by a lot of physics problems around batteries and storage and power. Back to materials again, I think is really the opportunity for breakthroughs here to try to do that. I would fully envision that one day, your home and your car and everything else is a node on a network that helps provide power instead of consuming it. Again, in the single-family home space, we're looking at advanced PV systems that are and battery storage bases. Storage for me in energy is equivalent to storage in computers. Computers didn't really take off and become this size until you got storage. Now where you can get terabytes in a small space now. So I think you have the same problem with energy. You have to create enough storage capacity for energy to really make it scalable across, applications like that. But for sure, those type of things are underway, and hopefully in the next couple of years, we'll see demonstrations of that.
What do you think? Any challenges on enabling that?
Yeah, so we've got a portfolio company called EverCharge, and it's a system that you would use if you'd like to retrofit it, add vehicle charging to a multifamily or a commercial property. And the reason why you need a system like EverCharge is because the buildings typically weren't designed to charge a lot of vehicles out in the parking lot. And then if you flip that and you're trying to run the building off of the vehicles out there, it's very difficult to retrofit. And so if a building is designed for it from the get-go, it's possible, but your cost gets bonkers very quick. You need a lot of very fancy solid-state switches, all kinds of stuff. And you have to have a cohesively engineered solution, and you probably need to have a sophisticated facilities person on call. So anecdotally, it's cool. I think it's more reasonable for like a single-family home where you just really want to plug stuff in, like a heater or air conditioner, stuff like that. But the building systems can get extremely expensive if you want that level of flexibility. I don't see it happening except for kind of high performance mission critical facilities where they like a hospital, they got a plan for that type of stuff because people will die if the power goes out. Right. I think that's kind of one of the few situations that you'd spend the money to have those types of solutions.
Yeah. So Eddie, Kode Labs is headquartered in Detroit, and they're making the Lightning in Detroit. I imagine that you got a phone call the following day for the Detroit customer saying, hey, we're going to switch to the Lightning. So does your system manage this, or what's going on?
I gotta think about how to word this. Similar to, we are under NDA with Ford, and we are working with Ford. I'll just say that.
That's a good answer. I'm excited about this
That's
answer.
a good answer, right? That's a good answer. Yeah.
Do we have any questions from the crowd? Anybody wants to come to the microphone and chime in? Anything you want to know about smart building technologies and smart buildings and building, pretty soon buildings will either get wheels or wings. And that's coming next too, right? So
I had one more comment on the building products, because you saw that a number of our investors, Cemex Concrete, Knauf Insulation, so we spent a lot of time trying to figure out, indoor air quality, all that. And we learned that Google spent a tremendous amount of money doing something that they called mapping the building biome and trying to figure out not just what's off-gassing from adhesives, but also what type of microbes are growing in the HVAC system and stuff like that. So they did all that research, and then they decided that it was dangerous to have this information, so they gave it to a nonprofit called the Healthy Building Network, I believe that's what it's called, in DC. And I spoke with the gentleman who runs that, and he says that this data set is if you try to bring attention to it, it's going into a political and legal buzzsaw. Because, all the adhesives manufacturers, all that stuff,
Big lobby.
as that data, as we become aware of how poisonous some of these chemicals are, there'll be massive class action lawsuits. That was one of our big takeaways from that. Because we're fortunate that our LPs, they make all of the building products with stable compounds, and they're very healthy. But a lot of the cheap stuff and some of the suppliers for some of the big name, home improvement stores, like, yeah, that data would really, screw up their business
Wow,
model.
that's like walking into a Motel 6 with a black light, looking for how the bed looks.
You walk in and walk right back out, right?
I have a question.
Yeah, I have a question. So some of the sensors in the buildings are obviously to detect like threats, especially for like gases and emissions. Do you think there will ever be sensors that are controlled by AI that will detect human threat or any kind, or people tampering with equipment, or more obvious physical threats?
Yeah, so you can get a computer vision algorithm trained like to 99.99 whatever you want. There's a lot of firms out there that'll do that. So it's a privacy and security thing, but the cool technology that I like in that field is called gait tracking. And even if they're wearing a mask, if you get 10 meters of that person walking on camera, you can identify them individually. You can tell if they're intoxicated. You can tell if they're injured, if they have a limp. You can tell what their intent is, because your walking posture is like a summary biometric. And the Chinese are doing it for all their citizens. And then it can be applied anywhere. You just got to train the algorithms. But yeah, it's amazing the amount of data you can get from video.
Yeah, I think the technologies are ahead of what maybe some of the acceptance in the business models. Like another one, for example, is like AI with audio, and smart audio is amazing what can be profiled. I was running connected audio for a while, and we were doing a lot of work with Bose at the time. And there's microphones that can detect in an automobile or in a house if there's a drip in a faucet, all the way to what model of product it is, just by the AI associated with being able to collect all that input from audio. They were looking at it from diagnostics in cars to be able to, hear a squeak, hear a rattle, know what it is. So I think that there's a lot of opportunity that's really interesting technology-wise, but it does get into privacy issues. It gets into a lot of just, so it's can the business model shift and align with makes what the investment required to make that reality feasible.
We've seen it used in first responders dispatch. So it's anticipatory natural language processing. So that was part of the Audrey project at the NASA Jet Propulsion Laboratory, part of the Department of, I forget which department was funding it. But yeah, it's really sophisticated AI that can hear what's going on the 911 call and give more context to the situation, even if the person can't talk. And it's, just listening certain things. And it's kind of like how you can finish someone's sentences if you know them really well. That's the type of artificial intelligence. And yeah, it's cool. But it's actually being used for first responders, 911. Like that's where it's going to be used. But totally right. Like, we have rights in America, and you're just not going to see that, ubiquitous. And I don't think you're going to have the cameras providing the level of security either. It's just, in our culture.
Yeah, so another thing we worked on too is not so much like external threats to buildings, but really, infrastructure threats to buildings from the standpoint of the methodologies used to build it, right? So if you think today, not many buildings are built in a componentized factory way. And at the end of the day, a building is a seamless, entity structurally, electrically, mechanically, environmentally, and cosmetically. So when you start to put pieces together, how you interconnect those things, against all those different parameters, and then how you monitor the life cycle of those was a big function of sensors. We had structural and seismic detectors and said, hey, we screw these walls together and they're separate walls, and you put them on a foundation and you start to get temperature and time. Do they move in the same fashion? Does it prevent or does it present a problem to the actual infrastructure or reliability of the building itself, over time? And how does the building age and wear? So we built, some systems to actually use sensors to detect that type of event, because we thought that would be important to be able to make reliability statements around, the construction and assembly methodologies and techniques that were put into place.
I also think there's one other area. There's niche areas that can maybe move those needles in prop tech a little bit. For example, if you want to have build your property value to have say, a single-family home that's more designed for disabilities, designed for retirement, designed for people to stay in the home longer. There's technologies like, there's sensor technologies that are already being put in floors that are like for merchandising mapping that can be applied to fall detection and tracking, an elderly person that could be geared towards a lower cost way to live as a senior. I think there's all kinds of technologies that could start to be integrated into homes and have a value proposition from that perspective that kind of maybe get around some of the privacy things if they're very specific like that.
Question? Yeah, sure.
Okay. So how do you make old buildings smart? I just moved into an older home, and it seems like smart technologies and modular construction is all about new construction.
Yeah.
So how do you retrofit? Do you see a big market for that, or are we all talking about new construction?
For aesthetics, we've got a company in Chattanooga, Tennessee that 3D prints building facades. So we can change the look of the interior, the exterior, laser scan it, and then 3D print something that'll just grab right onto it and protect, historic buildings. But then your exterior or the interior would all be changed. So you could use that to lock in asbestos, whatever you want. But that's one approach. Then HVAC systems, you probably want to upgrade that.
That sounds like a great business, putting lipstick on the pig, right?
I think the answer to that question, this is one of the things I've been thinking of in the whole time here. It's like when we say smart buildings or intelligent buildings, it's such a vast interpretation of what that means. I could say there's already, I think, a lot of products on the market that are geared towards aftermarket retrofit to make. So it really kind of has to zone in maybe on what you consider a smart building, because there's a lot of things that could go in. You can install today, a whole set of Ring cameras and doorbells and things. In a sense, from a security and perspective, you're making it a smart building. So maybe that may be a varied answer depending on what specific technology.
I'll give you my definition of a smart building. Flex Seal, baby. Flex Seal. You familiar with Flex Seal? Have you seen the commercials?
You can get at Walmart in a can, right? Just spray it on.
Did your boat sink yet?
That's
I
right.
made a boat out of a
That's right.
screen door.
So parting thoughts before we go to a lengthy break and before we listen to Bill Green from ARM, who is going to tell us how he's making all these freaking chips that are coming our way in all these buildings for all these sensors. Parting thoughts, Eddie. Where are the opportunities? How excited are you about the business you're in? Come and see me at Riverside. Parting thoughts.
Yeah. So now it's not intended to be a.
And are you a Cedar member?
I am now. I think. Yeah.
Awesome.
Great at sales, Andres. I think you're forcing us to be, if we don't want to. Happy to be a part of it. It's actually my second time in Texas. I think there's a ton of opportunity in just really the smart city, smart building space. Holistically, my personal opinion is that it's actually not that complicated of a space. It's because over the last decade or so, I think there's been a lot of movement and innovation in the space that actually simplifies, how a smart city can come together or a smart building can come together. I'm extremely excited to be in it. I'm hopeful that the traditional big companies that have been in the space for a long time will be forced by the startups that Curtis and others are investing into, open their systems up a bit and really talk about future tech, and not have systems where things are growing in them and there's nothing monitoring them because they've not had any incentive to do that. And now with these new systems that are coming on board, I think we'll see a healthier, better planet overall due to the startups that are coming out, and that's what I'm hyped about.
Yeah. Curtis?
Parting thought would be, do not hire an architect before you hire a contractor.
That's good.
Just words to live by.
Right. There you go. John?
I would say, I think when it comes to, this generalness that I was just talking about on smart buildings, when you're looking at technology and technology to when a technology is first developed to when it takes off in the market is often the big challenge of determining what that timeline is, what those triggers are. And I think you often see years and years and years, some technologies, they haven't gone anywhere, and then they just hockey stick at some point. I think when you're looking at the different products from thinking about how quickly they can get into the market, I think you can break down smart building products and ones that kind of, it's going back to kind of the concept of voice of the customer, innovation management. It's like, who is the decision maker in this purchase? Is it a product that's more to the individual and plays on a consumer emotion to buy that product, or is it more of an institutional technology that's really either through some type of subsidized initiative, like energy, or something that's more of a centralized building management, and then kind of look at that customer base. One of the things we were talking about is trying to take the product we're doing, and we were looking at Energy Star standards. And I brought up, I think there's a big difference. There's an Energy Star tag on a connected refrigerator, and there's one on a hot water heater. A consumer, I don't think, pays much attention to the one on the refrigerator. That's not what their feature set they're looking for, and that's much higher priority on the water heater. So it's shifting a commodity type building component into more of a value, kind of a want type product instead of a need type product. So
Yeah, that makes a ton of sense. Pat, any wisdoms and parting thoughts?
Yeah, so I think, as we said earlier, it's such a broad, category when you start to think about the technologies and things that can be enabled to make a building smarter, intelligent. For me, I'm bullish. I think the opportunity is as big as it will ever be. I've spoken on this several times. If there's probably hundreds of graphs out there that show the negative, 20-year history GDP of construction versus every other industry that's probably, averaging 20% growth year over year by leveraging technology. So I think the opportunity is very wide and very available. And I do see over the past couple of years, companies like Katerra that even, it was a failure from a business perspective, start to address some of the basic issues and the implementations and the ability to actually change the outcome. And as a result, save our planet, right? So I'm bullish that that's underway and that people will work on it. And as part of my work and company, we'll be building, affordable homes that I think will be extremely cost effective, extremely sustainable, and extremely desirable to live in, and be able to scale, rapidly across the U.S. So keep your eyes out for that, and hope to contribute to the benefits thereof.
Absolutely. Well, please, hand of applause for our esteemed panel.
Thank you.
And I encourage you to come next door, but come back here.